Good morning, friend. Today we have to start new topic, that is depend on topic related with the tangent. So already in first lecture we have discussed related with the circle and exercise 10.1. In exercise 10.1 generally we have concept related with the circle and its tangent. But today we want to discuss something related the number of tangent. In early chapter in early topic we have discussed about the definition of it. Now if you will see, there are three figures are at here. Before we start exercise 10.2, it is necessary to understand how many number of tangent from a point on a circle. If you will see at here, इधर देखा जाए तो there is a one point P which is inside the circle. So it is not a tangent. Can we call it tangent? No, because it is called secant. Because already we have understand in last lecture the definition of it. इसके पहले के लेक्चर में हमने देखा है कि सेकेंड का डेफिनेशन क्या है. So here P is inside the circle. In third figure you see that here it is called point of contact in last lecture. Point of contact. Point of contact. So here we can draw a tangent. It is a tangent and it is a point of contact. And also we have seen that perpendicular distance from it. That also we have seen in last lecture. It is 90 degree. And here O is a center. Now in first case point P is inside. So it is seconds. Here it is a tangent, but point P is called point of contact. But we have discussed the number of tangents. So here only one tangent. अगर देखा जाए तो पहले P अंदर है, फिर on the circle, now outside the circle in third condition. P is the outside the circle. So when P is outside the circle, we can draw two tangent. That is PT1 and PT2. If you will see the proper figure here, center it is. And here it is perpendicular always. And again here it is also a perpendicular 90 degree. So it is a O. And we can draw one line also like that. So but P is outside. So length of the segment of the tangent from the external point P and the point of contact with the circle. Here T is called point of contact. Point of contact. Point of contact. Here it is also point of contact. The length of the segment of a tangent from the external point P and the point of contact with the circle is called length of the tangent from the point to the circle. So length of the tangent, that is PT1 and PT2. PT1 and PT2 is called the length of the tangent. Another thing, if you will see it properly, the third figure, I also construct some more thing. इसमें हमने थोड़ा join कर दिया, सेंटर O को T1 से join किया, तो we can say OT1. It is also radius. OT2, it is also a radius. If you will understand the definition of it, we can say it is a radius. So what is the target now? Number of tangent from a point on a circle. So we can draw two tangent. Now length of it, that we have to prove in exercise 10 in theorem 10.2. Theorem 10.2 it should be asked in exam. वो exam में पूछा जा सकता है. So we go for now theorem 10.2. That is a statement. Theorem 10.2. Length of the tangent, length of tangent drawn from an external point to a circle are equal. If you will see the आगे के फिगर में हम लोग ने PT1 और PT2 मैंने बोला वो इक्वल होगा, लेकिन कैसे होगा, that we have to prove. So it is called theorem. The length of tangent drawn from an external point to a circle are equal. So what I have to prove? That is PQ is equal to PR I have to prove. So first of all you have to construct, that is called dot dot dot. ये डॉट डॉट है वो कंस्ट्रक्शन है, मतलब वी हैव टू ड्रॉ इट, दैट इज नॉट गिवन इन ए क्वेश्चन. So what is given? So first of all we have to write given every time. That what is given? A circle with center O and a point P lying outside the circle, and the two tangent PQ and PR on the circle from point P. That is called given. इसे given कहा जाता है. So again I am explain 3 marks from the chapter number 3. 3 marks theorem is there. 3 marks for theorem. So half marks for given, again half marks for figure, and half marks for to prove. So 3 things already we can draw it properly. So first is that is given. A circle with, एक circle दिया गया है with center O and a point P lying outside the circle, and two tangent PQ and PR on the circle from point P. That is not remember to write. What we have to prove? So from here to prove, that is a second. To prove that PQ is equal to PR. So given, that is we have to write first. Afterward to prove that we have to write second. Here it is a figure. We have to say it is a figure. Now proof. Now we have to write proof. So for proof, now we construct. That is why here it is construct. Construct means what? We have to construct it. We have to draw again something more for explanation. So join OP, join OP, OQ and OR. Join OP, OQ and OR. And so that is sufficient. So now again I am explaining proper way. First I erase something which is not necessary. Now if we will see the question, figure is there. What I have to prove? That is a statement, proof, and explain it. So what generally we have to, it is sufficient. One, that is given. To prove, that is second, and proof, that is third. That we have to write. Now construction. So join OP, OQ and OR. OP, OQ and OR, that we have joined. The OQP and ORP are right angle. Now we will see the tangents are always perpendicular. So here OQP, so OQP and ORP is a right angle, because these are the angles between the radii and tangent, and according to the theorem 10.1 they are right angle. So two triangles now we have to say. So name of a triangle now. Two right angle triangle is there. That is OQP, and triangle, if you will see OQP and triangle ORP and triangle ORP, that is ORP. So two triangle, if you will see properly, we have constructed. So now two triangles are there. So that is triangle 1, that is triangle 2. Now we have to prove related it. We have to, what we have to prove? So we have to prove that two triangles are congruent. If we prove two triangles are congruent, then we easily say that the according to the CPCT parts are also congruent. So first, that is in this theorem we have to prove that two triangles are similar. So how we can prove similar? By different criteria or identities. So now in triangle, two triangles are here. It is seen in figure. So OQ and OR. OQ and OR, radii of the same circle. So that is one. And OP is equal to OP common. OP is common. That is second. Here RHS, they prove that. Why? Because still now again I have to write angle OQP is equal to angle ORP. In bracket we have to 90 degree each. So three things. Again, right hypotenuse side. Right hypotenuse side. So first right angle, then hypotenuse, and then common, that is side. So here it is side. Here it is hypotenuse. And here it is right angle. Here it is right angle. Here it is side. Here it is hypotenuse. So according to the RHS criteria, two triangles are similar. When two triangles are similar, their corresponding part of congruent triangle are also similar. So we can say that this PQ is equal to PR. So PQ is equal to PR. Important, most important theorem related with the chapter 10. चैप्टर 10 में दो ही थियरम इंपॉर्टेंट है, 10.1 एंड 10.2. वो दो थियरम में से already first theorem we have discussed in earlier lecture, and today we have discussed this theorem. Now we go for the exercise. In exercise 10 sums are there. Out of it 5 we have to discuss today. Now we go for the exercise. So in this exercise 10.2, there are different type of sum, that is MCQ sums are there. So in board exam 30% is objective. So in board exam 30% is objective. So may be possible that in this lesson they are asked objective question like MCQs. Now question number 1. From a point Q, the length of the tangent to the circle is 24 centimeter. The figure is not given in question. From a point Q, you will see that from a point Q, the length of the tangent to a circle is 24 centimeter. So here it is a tangent, length of a tangent, that is PQ. And distance of Q from the center is 25. Distance from Q from the center is 25. Find the radius of a circle. So what I have to write in which triangle it is? It is a right angle triangle, that is angle O. In triangle OPQ, angle P is equal to 90 degree. So we apply Pythagoras. We can apply Pythagoras. By applying Pythagoras, we know that OP square plus PQ square is equal to OQ square. Now OP square, that is radius. Here it is a radius. PQ square, that is given 24 square. OQ square, that is given 25 square. So R square is equal to 25 square minus 24 square. That is 625 minus 576. That is 49. Sorry, it is 625 minus 576, that is 49. So R square is equal to 49. Therefore R is equal to 7 centimeter. So radius is 7 centimeter. So here it is, option is A. So that type of questions asked in board exam, government exam, in even though GK based question, TST exam, NTSC exam, in different exam, that type of sums may be asked. बहुत easy sum है. क्या किया, एक सर्कल था, उसका एक सेंटर है, बाहर एक पॉइंट Q है, वहां से एक टेंजेंट ड्रॉ करेंगे तो सर्कल को P में अटैच होके जाता है. उसके बाद if you will draw OP, then it is called radius, and OQ is given and PQ is also given. We have to find out OP. radius ढूंढने का था. By applying the Pythagoras, Pythagoras means hypotenuse square is equal to sum of its two sides. इस तरह से we have get answer. We go for next question now. 3 questions are there for correct option and give justification. So that is a justification. Now question number 2. In question number 2, you will see that in figure, TP and TQ are the two tangent to a circle with center O. So you will see the figure. Here it is a point. Outside the circle there is a point T. Two tangents, that is TP and TQ. We know that the tangents are equal. We know that the tangents are equal. So TP and TQ are the two tangent to a circle with center O. So that POQ, that is given 110, that is given. Then PTQ we have to find out. PTQ we have to find out. That. But we know that tangents are always perpendicular according to the 10.1 theorem. So first of all, what I have to write? It's a quadrilateral or not? So O, P, T, Q is a quadrilateral. It's a quadrilateral. So we know that sum of angle is equal to 360. Or in different way we can say, now angle POQ, that is 110, plus angle OQT plus QTE plus QTE plus TPO is equal to 360. But two angles have 90 degree because of tangent, that is angle P, here it is angle P, and angle Q, so it is 90. So now POQ, that is 110 plus 90 degree plus QTP, that we have to find out, or PQT plus 90 is equal to 360. So if you will total it, 180, 90 plus 90, 180 plus 110, 180 and 110. So 360, so QTP is equal to 360 minus 290, that is 70 degree. Or another way, what you have to remember, opposite angle, that is angle P plus angle Q is equal to 180. Same thing, angle O plus angle T is equal to also 180. Here 90, that is already. Now if I want to find out T, then T is equal to 180 minus angle O, that is 110, that is 70. So two different way I will give the answer. PTQ. So here it is 70. So both different way we can solve this, either by applying quadrilateral and theorem 10.1 criteria. The angles, here it is 90, here it is 90. That is given in question. So we can easily find out QTP, that is 70 degree. One more sum, that is question number 3. Here options are given, but for justification we have to explain the sum properly for justification. If tangent PA and PB from a point P to a circle with center O are inclined to each other at angle 80, then find POA, then POA, or find POA. So if you will see that P, then O and A, so we have to find out this. So in early discussion in question number 2, you will see that is a quadrilateral or not. So in quadrilateral, 360 degrees is there. So here it is 90 given, here it is 90 given. Already we know that in first question or second question. So now PA and PB are the two tangents of the circle. So these are all the tangents. So already we know the tangents are equal. So PA and PB are the two tangents of a circle. And here it is 90 degree. So radius is perpendicular to the tangent according to the theorem 10.1. Therefore OA perpendicular to PA and OB perpendicular to PB. Therefore OBP is equal to 90 degree and OAP is equal to 90 degree. So already in last question I have discussed like that, same 90, 80, 90, then we have find out the BOA. So BOA that we have find out, that is 100 degree. So we have got 100 degree. But we know that these two triangles are similar, that we have to prove. How it is proved that these two triangles are similar? See now, if you will see the two triangles are that we have to write. So OPB and OPA. OPB. So here one triangle is there. Another triangle OPA, that is OPA. So this triangle and this triangle. So two triangles are there. If you will see that we have drawn two different triangles here. That is PBO. Another triangle we can draw like that. That is PAO. So here it is common in both. Here B is equal to 90, A is equal to 90, and here it is a radius. It is a radius. So that is at here. AP is equal to PB, tangent drawn from external point. AP is equal to AP. So here it is AP. Is equal to BP here. And OA is equal to OB, radii. OA, here it is radii. Here it is also radii. And OP is common between them. So we can, by SSS theorem, two triangles are similar. When two triangles are similar, then angles are also congruent. So which angle is congruent? POB is equal to POA. These two triangles are similar. That is 1 and 2. So angle 1 plus 2 we know that is 100. Angle 1 और angle 2 का total कितना था? 100 था. But both angle are same. So 100 divided by 2 we can get answer 50. So 50 is a correct answer. So there are different, if you will see that question 1, 2 and 3 all are MCQ based questions are there. Now in next question we can solve this. When question something is given, we have to draw the figure and then we have to solve. So here it is a one proof. So question 1, 2 and 3 we have completed. I think now we go for question number 4. That we can do in the next lecture.